In this section, we are going to look at how do we find the matrix of transformation given the object and the image. So, for example, you have that is your object, it is transformed to this. How do you find now the matrix here? So that is what we'll be dealing with in the second lesson of matrix and transformation. I want to put an example here which is going to guide us on how do we go about it. A rectangle with the vertices. We have the vertices A, it is 3, 4. We have B, so our B is 3, 1. We have our C, we have 5, 1. And we have our D, which is 5, 4. That is, and D is mapped onto a rectangle, is mapped onto a rectangle whose vertices are A prime, we have it is -4, we have 3, we have B prime, we have it is -1, 3, -1, 3, we have C prime, here we have commas, of course, forget to do that. We have C prime, it is -1, 5, and D prime is D prime is -4, 5. Describe the transformation. Describe the transformation. Describe the transformation and find its matrix, and find its matrix. So in this scenario, what we have been given is a rectangle and its vertices. So we have the object. I can say the object has a coordinate that is A, which is 3, 4. We have B, we have 3, 1. We have C, we have 5, 1. And we have D, which has coordinates 5, 4. Then we have image, that is image, the coordinates of the image. We have A prime, the image of A. We are being given -4, 3. We have B, that is -1, 3. We have C, we have -1, 5. And we have D, which is -4, 5. So those are, so now you realize that there before we were looking for the image, whereby we were provided by the transformation matrix and the object, and we multiply that. So in this case we have been provided by the object and the image. So let's see how do we find the, first of all we are going to plot the two figures, that is the object and the image, to see and be able to see the kind of transformation that is there. Then we look for the matrix. So this is the grid that I'm going to use. Let's first of all write the coordinates of our object. We have A, it is 3, 4. We have our B, it is 3, 1. We have our C, which is 5, 1. And we have our D, which is 5, 4. That was the first thing we brought the object. So we start here, that's the origin. We have 1, 2, 3, 4, 5. So that is our y-axis. Then x-axis we have 1, 2, 3, 4. We have 5, we have 6. Can say that is our x-axis. We have -1, -2, -3, -4. So let's start by plotting the the object. So 3, 4, we have our point, that is our A. We have our B is 3, 1. So 3, 1 is there, so we have our B. We have our C is 5, 1. This is C, and we have our D is 5, 4. So that is our object triangle. So what remains here is to join the four points and come up with a rectangle. So this is a rectangle that we have come up with. Then we can say our image, we have A prime, it is minus 4, 3. We have B prime, it is, that is B prime. We have minus 3, minus 1, 3. We have C prime, it's, okay, we can put it down here. We have, so we have, this is our C prime. The coordinates are minus 1, 5. And we have our D prime. Our D prime is minus 4, 5. So those are the coordinates of the image. So we start with A, minus 4, 3, minus 4, 3. We have our A prime. We have our B, minus 1, 3, minus 1, 3 is there. So that is our B prime. C is minus 1, 5. So this is our C. And we have D is minus 4, 5. So this is our D prime. So we join the 4 points to come up with the image. So that is our image. If you look at the object and the image, we can say it is a rotation. So it is a positive quarter turn, that is negative, positive 90 rotation. So that is a rotation. If you don't know how to determine that, you can join A and to the origin and A prime to the origin. You measure the angle. You join B to the origin and B prime to the origin. You measure that angle. You will be able to find that it is 90 degrees. Now what remains, we are supposed to determine the matrix of transformation. So to determine that, what we say let the matrix B be represented by A, B, C, and D. Now, what we saw in the first lesson is that if we multiply the transformation matrix by the matrix that will be formed by the object, we should get the matrix that is formed by the vertices of the image. So we will come and say, if we say A, B, C, and D, that is our transformation matrix. If we multiply by the matrix of the object formed by the vertices of the object, we have 3 and 4, we have 3 and 1, we have 5 and 1, and we finally have 5 and 4. So that is a matrix. When you multiply that, we are supposed to get the matrix that is to be formed by the vertices of the image, that is minus 4. You just invert the coordinates, and we have 3. We have minus 1. We have 3. Then we have minus 1. We have 5. We have minus 4. And we have 5. So if we are able to get A, B, C, and D, then it means that we have obtained the matrix of transformation. So here, you come and say we multiply A multiplied by 3, that will give us 3A, and B multiplied by 4 plus 4B. So that is the first element. A multiplied by 3, we get 3A plus that is B multiplied by 1, so that is B. Then we have A multiplied by 5, that will give us 5A plus B, that is B multiplied by 1. And then we have, finally, we have A multiplied by 5, we have 5A plus, that will be B multiplied by 4, 4B. So the other one is C multiplied by 3, that will give us 3C plus 4D plus 4D. Then we have 3C plus B plus D. Then we have 5C plus D, and we have 5C plus 4B. B. So that is a matrix that you get when you multiply the transformation matrix by the matrix of the object. It should be equals to the matrix minus 4 3, and we have minus 1 3, we have minus 1 5, and we have minus 4 5. So that is what we get there. Now when you are running the matrices in form 3, we learned that matrix elements, if two matrices are equal, the corresponding elements are the same. This means that so because of space, then we are going to use another board to be able to solve this. So we are going to equate the corresponding elements of the matrix. This matrix equate the corresponding elements of the other matrix and see whether we will be able to get the values of A and B, C and D. So this is where we'll continue from here. So we have 3A plus 4B, then we have 3A plus B, and then we have 5A plus B, and we have 5A plus 4B. That is the first row. The other row is 3C plus 4D. We have 3C plus D. We have 5C plus D, and we have 5D plus that is 5C not D, 5C plus 4D. So that is the first matrix. And then we have it is equals to we have minus 4, we have minus 4 3, we have minus 1 3, we have minus 1 5, and we have minus 4 5. So like I've said, if two matrices are equal, then the corresponding elements of the two matrices are equal. So we are going to say 3A plus 4B should be equals to the corresponding element, which is minus 4. Again, this element is equals to that. So we say 3A, and then we have plus B is equals to minus 1. So this is a simultaneous equation we can solve. And since we can be able to eliminate 3A, we subtract. So we have 3A minus 3A is 0. 4B minus B is 3B is equals to minus 4 minus minus 1 will be minus 4 plus 1, which will give you minus 3. Divide both sides by 3, you get B is equals to minus 1. When you get B is equals to minus 1, you can substitute in the second equation, that is 3A plus minus 1 is equals to minus 1. That is the second equation. Take minus 1 to the other side, becomes positive. So minus 1 plus 1 becomes 0. So 3A is equals to 0. Divide both sides by 3. You divide by 3, you get our A is equals to 0. So that is, we have gotten the values of A and B. Again, we come to the second row. We say that 3C plus 4D is equals to the corresponding element, which is 3. Then we have 3C plus D is equals to the corresponding element, which is 3. We can eliminate C by subtracting, and therefore we have 3C minus C is 0. 4D minus D is 3D is equals to 3 minus 3 is 0. Divide both sides by 3. Divide by 3, you get D is equals to 0. We substitute in the second equation, so 3C plus 0 is equals to 3. Divide both sides by 3. By 3, you get C is equals to 1. Therefore, we can say that our matrix A, B, C, D should be equals to our A is 0, our B is minus 1, our C is 1, and our D is 0. So that is what we had assigned as a matrix of transformation. So that is how we get the matrix of transformation. If when you are given an object and its image after transformation, then what you do, you assign your transformation matrix to letters, and then when you multiply, you solve as the linear equations that you've performed, and that way, after you solve the linear equations, you'll be able to come up with the matrix of transformation. So we are going to do another example and see whether we'll be able to do that. We are told a triangle PQR, whose matrix vertices are, we have our P is 2, 5, our PQ, our Q is that is, we are given, and our R is 4, 2, so that's a triangle, is mapped onto triangle PQR prime, that is PQR, whose vertices are we have our P prime is -5, and -5 -2, we have Q prime, we have -2, 2, and R prime is -2, 4, by a matrix T, T. So find matrix T. Find matrix T. So that is a question. In this case, we are not going to draw the circle, the triangle, because we are not required to do that. What we will do is to say, so we say let T is equals to A, B, C, and D, and therefore when we multiply the two matrices, when we multiply, if that is our matrix, so when we multiply A, B, C, and D, we multiply by the matrix that be formed by the object, that is 2, 5, P, our Q is 2, 2, and our R is 4, 2. We should get the matrix of the formed by vertices of the image, which is -5, -2. You just invert the coordinates, so -2, -2, and we have -4, and not -4 but -2 and -4. So if we multiply that and form the linear equations, and we solve for A, B, and C, and D, then we have obtained the matrix of transformation, or the matrix P. So when you multiply A multiplied by 2, that should give you 2A, and B multiplied by 5, we have plus 5B. Then we have 2 multiplied by A, that will give us 2A plus 2B. Then we have 4 multiplied by A, we have 4A plus 2B. The other row we will have 2C, that is 2 multiplied by C plus 5 multiplied by D, that will give us 5D. So we have 2C and plus 2D, and the other one is 4 multiplied by C, that's 4C plus 2D, that is one matrix. It should be equals to minus 5 minus 2, we have -2, -2, we have -2, and -4. So that is a setup. So we now say, since the two matrices are equal, we are going to equate, that is this matrix 2A plus 5B is equals to -5. So let's put that bracket correctly, -5. So when we equate that, we'll be able to solve for A, B, C, and D. So we equate the corresponding elements. So we have 2A plus 5B is equals to the corresponding element is minus 5 on the other side. Then we take the second one. We have 2A plus 2B. It corresponds to minus 2. So these are linear equations. We can eliminate A by subtracting. So if you draw a line there, 2A minus 2A is 0. 5B minus 2B is 3B is equals to minus 5 minus minus 2 is minus 5 plus 2, that will give you minus 3. You divide both sides by 3, you get B is equals to minus 1. Once you get B is equals to minus 1, then you can substitute in one of the equations. So for example, in the second equation, you can 2A plus this will be 2 times minus 1, that is minus 1. When you take it to the other side, it becomes positive. So minus 2 minus plus 2, that is 0. So you divide both sides by 2, you get A is equals to 0. So we have obtained our A and B. Again, we come to the second row. We say that we can put this as 2C plus 5D is equals to the corresponding element is 2 minus 2, and the other one is 2C, the second one, plus 2D is equals to the corresponding element is minus 2 again. So we put a line there, so we can close a bracket. We can subtract so that we get rid of C. So C minus 2C minus 2C is 0. 5D minus 2D, that will give us 3D. This is minus 2 minus minus 2, that will be minus 2 plus 2, that will give you 0. So if you divide both sides by 0, D is equals to 0. If you substitute in one of the equations here, for example, the second one, 2C plus 2 times 0 is 0 is equals to minus 2. You divide both sides by 2, you find that C is equals to minus 1. Therefore, our transformation matrix, we can put it here and say our transformation matrix, our A is 0, our B is minus 1, our D is 0, and not that is not D, but C. Our C we have found is minus 1, and our D we have found it is 0. So that is the transformation matrix. So that is how you get the transformation matrix, given the object and the image, and that is how you get the answer. So let's look for another example. In our example 3, the vertices of a triangle ABC are A 2 2, B 4 2, and C 4 6. A transformation maps the triangle onto triangle ABC prime with the vertices A prime minus 1 minus 1, B prime minus 2 minus 1, and C prime minus 2 minus 3. Describe the transformation and its matrix. So here what we need to do is to plot the two triangles, that is the object and the image, and look at them and see what kind of transformation it is. But before we go to the grid or to the graph paper, let's first of all find its matrix, the transformation. So we say let the matrix be A, B, C, and D. So what I have said is that if you multiply this matrix by the matrix of the object, you should get the matrix of the image. So we say we have A, we have B, we have C, we have D. We multiply by the matrix of the object, which is 2, 2. We have 4, 2, and we have 4, 6. You multiply should be equals to the matrix of the image, which is minus 1, minus 1, minus 2, minus 1, and we have minus 2, and minus 3. So when you multiply these two, then you should be able to get the image. So we say this is 2a multiplied by, but a multiplied by 2 is 2a. So 2a and b times 2. So you have plus 2b. Then we have a multiplied by 4, that will give you 4a plus 2b. Then we have 4a plus 6b. So that is the first row. We come to the second row. We have 2c plus 2d. Then we have 4a plus 2d. And we have 4c plus 6d. We close the bracket and we multiply by, or we say this is equals to the matrix minus 1, minus 2, minus 2. We have minus 1, minus 1, minus 3. So that is the matrix. So we say that if two matrices are equal, then the corresponding elements are equal. This is to say that if we have 2a, maybe we use a different color. So we have 2a plus 2b. That should be equals to minus 1, the corresponding element on the other side. And then we have 4a plus 2b should be equals to the corresponding element is minus 2. So we have formed two simultaneous equations which we can solve, and because 2 and 2b and 2b is we can eliminate, we subtract. So this will give us, when you subtract this, this is minus 2a is equals to minus 1 minus 2. It will be minus 1 plus 2. So that will give you 1, implying that our a is equals to, we divide both sides by 2, is minus a half. Once you get minus a half, you substitute minus a half in one of the equation. So for example, we have 2, you multiply by minus a half, we say it plus 2b, that is plus 2b is equals to minus 1. So once this will give you, when you cancel, divide 2 by 2, you get it is 1, so minus 1. So you take it to the other side, it will be positive 1, implying that our b is equals to 0. So we have obtained a and b. So what remains now is to work on c and d and see what we get. We now take 2c plus 2b, that is 2d, it should be equals to the corresponding elements, that is minus 1. This that is minus 1 there. And we take the second one, this is supposed to be c, so we take 4c plus 2d is equals to the corresponding element is minus 1. So these are two simultaneous equations. We can eliminate d, so we subtract. So you come and say 2c minus 4c, that will give us minus 2c is equals to 2d minus 2d is 0. And this will minus 1 minus minus 1, that will give us 1 minus 1 plus 1, which is 0. So if you divide both sides by 2, you get c is equals to 0. So if you substitute in our equation here, this equation here, so we substitute c to 0. So we have 2d is equals to minus 1, implying that our d is equals to, you divide both side by minus 2, by 2, that is you get a half. So we have obtained our d, our c, our b, and our a. So we now have our matrix, that is a, b, c, and d. Then it is equals to our a, we found it is minus a half, our b we found it is 0, and our c we have found it is 0, and our d we have found it is minus a half. So that is a matrix of transformation which transformed triangle ABC onto triangle ABC prime. So that is how you get the matrix. Now from there, we now go to our graph paper and plot the two triangles and see what kind of transformation is represented by this matrix. This is the grid that I'm going to use. Let me first start by putting our coordinates. So we have our A is at 2, 2. We have our B is at 4, 2. We have our C, it is at 4, 6. Those are the coordinates of the object. Then we can have our A prime is at -1 and -1. Our B prime is at -2, -1, and our C prime is at -2, -3. So with that, we can now plot the object and the image. We start by first of all labeling our axis. So we have 0, we have 1, 2, 3, 4, 5, 6. That is our x-axis. We have 1, we have 2, 3, 4, 5, and 6. That is our y-axis. From there, we can put the negative side, -1, -2, -3, and we have -1, -2, -3. So with that, we now plot our object. So this is where we have our A. This is our B is at 4, 2. So that is where we have our B. Our C is at 4, 6. So this is where we have our C. And therefore we join the 3 points to come up with the triangle. So that is our triangle ABC. And with that, we plot the image now. So our image, we have A prime is at -1, 1. So this is where we have A prime. B prime is at -2, -1, -2, -1. So that is where we have our B prime. And our C prime is at -2, -3. This is our C prime. We join the 3 points to come up with the image. So this is our image that we have. So what is the transformation? If you observe the object and the image, you can see that this is an enlargement, and if you count the length of AB, this is 2 units and this is 1 unit. So it is an enlargement where the object is diminished, which we can say center of enlargement. Center of enlargement is the origin, that is 0, 0, and enlargement scale factor, enlargement scale factor that is a half. That is a half, and it is minus because the image is on the opposite side of the object. That the minus, that is what the minus implies. And remember our transformation matrix, which we worked out, was we got it is minus a half, 0, 0, and minus a half. So that is how you work out that. You get the matrix of transformation the way we have worked it earlier, and when you plot, you should be able to observe. If you are not able to get the enlargement, you can join a line. Let's see, we can join the lines A to A prime, B to B prime, and C to C prime to see how it looks like. So you can see when we join the 3 points, that is A to A prime, they all pass through the origin, that is 0, 0, confirming that that is the center of enlargement. And if you measure the distance from A to the center of the enlargement, that is 0, 0, you can even use a square. You can see here 1, 2. This is 1. So it means that this is how we get the enlargement scale factor that we get by putting the length of the image and the length of the image. So if you take this is from the origin to A, it is 1. You divide by from the origin to A, it is 2. That is, this is 1, 2. Then you find that is you confirm that is a enlargement scale factor. And because it is the image is on the opposite side of the object from the center of enlargement, we put a minus to indicate that. So that's how you do that. If you are not sure of that, you go back to Form 2 where you did enlargement and revise on that. You can check on my video on this. You'll be able to understand how we get the center of enlargement and the enlargement scale factor. So that is how you work out that. So I hope now it is clear. That was my objective, to show you how we get the matrix of transformation, and how to describe the transformation as a result of that transformation. So I hope it is clear, and now once you get such kind of a question, you should be able to work it out. Let me give you just a few questions for you to try. Once you are through, you can send them to my email or to my WhatsApp number. I'll be able to advise whether you have understood the concept or not, and then we can see what we can do. So try these 3 questions. Just follow the procedure that we have followed with the other examples that I have done, and you should be comfortable. Once you are through, you can send them to me through the email that I will provide at the end of this lesson, or my WhatsApp number. So thank you for watching, and I hope this helps you in your revision or running.